When stars die, they explode. But what if I told you that one star did it twice? In 2025, astronomers made a discovery that changed the way we understand stellar explosions. They were examining the remains of a supernova called SNR 050967.5, located in the Large Magellanic Cloud, roughly 60,000 light-years from Earth. Using the Very Large Telescope at the European Southern Observatory, they captured images of the remnants in unprecedented detail. At first, everything looked familiar. A bright explosion, expanding shells of matter, scattered stars in the background. But then, something unusual appeared. Two distinct layers of calcium. Two separate shells, concentric, one inside the other. It was as if the star had exploded twice, once in a small flash at the surface, and then in a massive, devastating core explosion. No one had ever captured this directly before. Not in theory, not in reality. And here it was, a real star leaving behind two clearly visible explosions. For decades, scientists had debated this. Some thought it was impossible. Others suggested it could happen, somehow. And now, finally, there was proof. To understand why this is remarkable, we need to look at the star itself. SNR was a white dwarf, a dense remnant of a star that had exhausted its fuel. Over time, it accumulated helium on its surface. Just enough helium could trigger a tiny detonation, the first explosion. Astronomers saw this first flash in the outer layer, a thin shell of matter pushed outward at incredible speed. And then, just 2 seconds later, the core detonated. The main explosion obliterated the star completely, sending matter flying into space, but leaving the outer shell from the first flash intact. SNR is located about 60,000 light-years from Earth. That may sound like a huge distance, but in cosmic terms, it's actually relatively close, only a tiny fraction of the Milky Way's size. This proximity allowed astronomers to capture these events in unprecedented detail. Using the Very Large Telescope in Chile, they were able to image both layers frozen in space, providing the clearest evidence yet of a double detonation supernova. For scientists, this was like catching lightning in a bottle, a rare and beautiful glimpse of stellar physics in action. Here's how it works. The white dwarf collects helium on its surface from a companion star or leftover material. When enough helium accumulates, it ignites. The surface layer explodes, sending a thin shell outward. This initial flash triggers the core to detonate. The star's dense core explodes violently, producing the main supernova. Both explosions leave distinct shells, each with its own chemical signature. This mechanism had only existed in theoretical models before. Now, thanks to these observations, scientists could see the double detonation in action. The inner shell, made mostly of calcium, traces the helium flash. The outer shell, richer in heavier elements, comes from the core explosion. It's a cosmic puzzle finally falling into place. You might be asking, why does this matter to us? Type supernovae are the standard candles of the universe. We know how bright they should shine. This allows us to measure how far away they are, and measuring distances in space is crucial. By knowing distances accurately, we can calculate how fast the universe is expanding. This, in turn, helps us study dark energy, the mysterious force accelerating that expansion. But if we didn't fully understand how these explosions worked, our measurements of cosmic distances could be slightly off. Now, thanks to SNR, we finally see the full mechanism. For the first time, scientists have a direct visual proof of the double detonation. This doesn't just confirm theory, it improves our ability to measure the universe itself. What's truly astonishing is the timing. The first detonation, the helium layer, happens just 2 seconds before the main core explosion. 2 seconds. That's all it took to trigger a process that would destroy a star and leave a cosmic fingerprint visible tens of thousands of years later. Astronomers can see the two layers moving outward, each telling a story of a flash of energy, a pulse of material, a chemical trace left in the void. It's a cosmic choreography, timed perfectly, and now captured in our telescopes. Imagine the team of astronomers staring at these images. Decades of theory, debate, and predictions collapsed into a single frame. Two shells, two explosions, frozen in time. The outer layer from the helium flash, the inner layer from the core detonation. For some, it was shocking. For others, beautiful. This star lived millions of years and then died in 2 explosive seconds, leaving behind a story written in light and matter.